chemistry is defined as the study of the composition, structure, and properties of matter, and the reactions by which one form of matter may be converted into another form. Chemistry is an active evolving science, and has vital importance to India and entire world. The subject has very ancient roots, but it is a modern science. The basic knowledge of chemistry is essential for development of subjects like physics, biology, geology, engineering, environmental science, and many other subjects. Therefore, chemistry is called as central science. In 21st century, the subject chemistry witnessed tremendous growth. During 20th century, the knowledge about chemistry has increased so much that the subject chemistry is divided in several branches as follows. Physical chemistry. The branch of chemistry that deals with the structure of matter, the energy changes, and the theories, laws, and principles that explain the transformation of matter from one form to another. Inorganic chemistry. This is the branch of chemistry that deals with chemistry of elements other than carbon, and of their compounds. Organic chemistry. This is the branch of chemistry that deals with the reaction of the compounds of carbon. Analytical chemistry. This is the branch of chemistry dealing with the separation, identification, and quantitative determination of the compositions of different substances. Biochemistry. This is the chemistry of the substance, consisting of living organisms. Pharmaceutical, environmental, nuclear, are also some more branches of chemistry.
Classification. Solids, liquids, and gases. Matter can be classified into three categories according to its physical state. These three categories are solids, liquids, and gases. 1. Solids. An object is said to be a solid if it has a definite shape and volume that cannot be changed easily. Some common examples of solids are chair, table, iron, common salt, sand, wood, etc. Solids have relatively high densities and are generally incompressible. 2. Liquids. An object is said to be a liquid if it has a definite volume but changes shape quite easily. A liquid flows to take the shape of the container. Some examples of liquids are water, milk, kerosene oil, gasoline, cooking oils, mercury, bromine, etc. Liquids also have high densities, but their densities are lower as compared to solids. Liquids are also almost incompressible. Solids and liquids are also known as condensed states of matter because of their well-defined volumes. 3. Gases. An object is said to be a gas if it has neither definite volume nor definite shape. A gas occupies whole of the space that is available to it. Thus, a gas acquires the volume and shape of its container. Gases have relatively low densities and are highly compressible. Some common examples of gases are air, steam, acetylene, methane, hydrogen, etc.
Pure substances versus mixtures. Pure substances have a definite chemical composition. They always have the same properties regardless of their origin. Mixtures have no definite chemical composition and hence no definite properties. Examples of pure substances: pure metal, distilled water, etc. Examples of mixtures: paint, mixture of oils, pigment, additive. Concrete, a mixture of sand, cement, water. Pure substances are further divided into elements and compounds. Elements are pure substances which cannot be broken down into simpler substances by ordinary chemical changes. Elements are further classified as metals, nonmetals, and metalloids.
Metals: gold, silver, iron, copper, aluminium, magnesium, calcium, sodium, platinum are a few metals. Metals have luster. The metals are hard. Wire or sheet can be made from metals. Metals are good conductors of heat and electricity. Metals lose their valence electrons to produce positively charged ions, that is, cations. Physical properties of metals. 1. Physical state. Under ordinary temperature, metals stay in solid state. However, metals like mercury and gallium are exception, which are in liquid state even at room temperature. Can you recall? You might have seen a doctor's pressure gauge to measure blood pressure during your visit to a dispensary accompanying your relative. Pressure gauge is an instrument used to measure blood pressure. In that, you might have seen a grey-colored liquid in a glass tube. What is that metal? The metal in a glass tube of a doctor's pressure gauge to measure blood pressure is mercury. 2. Luster. Take copper vessels at your home. Scrub them with lemon and rinse with water. Observe the luster before and after cleaning. Light gets reflected from the cleaned or freshly cut surface of metal and the metal looks lustrous. 3. Hardness. Generally, metals are hard, not soft. Exception: sodium and potassium are soft and can be easily cut by a knife. 4. Ductility. Have you ever gone to a goldsmith's shop? Have you seen the goldsmith making a wire of gold or silver? When a metal is pulled through a hole, its wire is formed. This property of metal is called ductility. 5. Malleability. Take an iron nail. Place it on a platform and keep on hammering it. After some time, you will see a thin sheet forming. This property is called malleability of metals. 6. Conduction of heat. Take a copper plate. Fix some wax at one of its ends. Heat the other end and observe what happens. Discuss with teacher. First, the wax melts. Second, this is because copper is a good conductor of heat. Third, when one end of copper rod is heated, the heat is transferred to the other end and hence the wax melts. Metals are good conductors of heat. Silver, copper and aluminium are the best conductors of heat. 7. Conduction of electricity. Which metals are used to make electrical wires? Metals are good conductors of electricity. Lead is an exception, which is neither a good conductor of heat nor a good conductor of electricity. 8. Density. Metals have high density. Sodium, potassium and lithium are exception, having lower density than water. The density of lithium is only 0.53 grams per cubic centimeter. 9. Melting point and boiling point. Generally, metals have high melting points and boiling points. Exceptions: Hg, Ga, Na, K. 10. Sonority. What is the metal that your school bell is made of? Metals used to make school bells are copper and tin. Note: bronze is an alloy of copper and tin and is used to make school bell. How does a school bell function? School bell is made up of metals. Metals are sonorous. Hence, school bell produces sound on striking. Non-metals. Carbon, sulfur, phosphorus are a few non-metals. Generally, non-metals are brittle and non-lustrous. Non-lustrous means non-shiny. Physical properties of non-metals. 1. Physical state. At ordinary temperature, non-metals occur as solids, liquids and gases. For example, solids, carbon, sulfur, phosphorus, liquids, Br2, bromine, gases, hydrogen, nitrogen, oxygen. 2. Luster. Non-metals do not have luster except diamond and iodine crystals. Some non-metals are colorless while others have different colors. What is the color of carbon in the form of coal? Sulfur is yellow and bromine is brown. 3. Brittleness. Take coal and hammer it. See what happens to it? Solid non-metals are brittle. Some non-metals are soft. Diamond, an allotrope of carbon, is an exception, which is the hardest natural substance. 4. Ductility and malleability. Non-metals are neither ductile nor malleable. 5. Conduction of heat and electricity. Non-metals are bad conductors of heat and electricity, except graphite, which is an allotrope of carbon, which is a very good conductor of electricity. 6. Density. Non-metals have low densities. 7. Melting and boiling point. Non-metals have low melting and boiling points. Exceptions: the solid non-metals carbon and boron melt at high temperature. Metalloids. Some elements such as arsenic, As, silicon, Si, germanium, Ge, antimony, Sp, have properties which are intermediate between metals and non-metals. Such elements are called metalloids. Compounds. Magnesium ribbon burns with a dazzling white flame to form a white ash. The white ash formed is magnesium oxide. It is an entirely new substance. Now, magnesium and oxygen are elements. They have combined to form magnesium oxide, which is a compound. Thus, a compound is a substance which forms when two or more elements combine in a fixed ratio by mass. The table here lists a few compounds and the elements that combine to form the compounds. Some compounds and their constituents. Elements sodium and chlorine combined form a compound, sodium chloride. When elements hydrogen and oxygen combine, they form water. Carbon and oxygen combine to form carbon dioxide, while sulfur and oxygen combine to form sulfur dioxide. Elements sodium and oxygen combine to form a compound, sodium oxide. And elements silver and chlorine combine to form compound, silver chloride. Properties of a compound. Let us now discuss the properties shown by a compound. A compound cannot be separated into its constituent elements by physical methods, but can be separated by chemical methods like electrolysis. This can be understood with the fact that water, which is a compound of two elements, hydrogen and oxygen, combined in a fixed ratio by mass, cannot be separated into hydrogen and oxygen by simple physical methods like sublimation, filtration, etc. But water can be broken down into its constituent elements, hydrogen and oxygen, by passing electric current through it. The properties of a compound are entirely different from the properties of its constituent elements. For example, the properties of hydrogen and oxygen are entirely different from the properties of water, which is formed by combining hydrogen and oxygen. Oxygen gas supports burning, hydrogen gas can burn, and water, which is formed by their combination, neither burns nor supports burning. In fact, water is used to extinguish fire. Isn't that amazing? A compound is formed when constituent elements combine in fixed ratio by mass. To form one molecule of water, the two elements, hydrogen and oxygen, combine in the ratio 1:8 by mass. A compound is formed when two or more elements combine with each other chemically. We cannot get carbon dioxide gas by simply mixing carbon and oxygen. They chemically combine to form carbon dioxide gas. Do you remember the activity in which you burnt magnesium ribbon in the presence of air? Magnesium and oxygen combine chemically to form magnesium oxide, which is a compound. Magnesium plus oxygen, which is present in the air, burn to give magnesium oxide. Energy is either absorbed or released when a compound is formed. When we burn coal, a lot of heat is produced along with the formation of carbon dioxide, which is a compound. We can write this as coal plus oxygen from air, burn to give carbon dioxide gas plus heat. What is a mixture? Mixtures are constituted by more than one kind of pure form of matter known as a substance. A substance cannot be separated into any other kinds of matter by any physical process. We know that dissolved sodium chloride can be separated from water by the physical process of evaporation. However, sodium chloride is itself a substance and cannot be separated by physical process into its chemical constituents.
Subscribe to my channel. Click on bell icon to get notification about new video.